What is this chapter called?
Vectors.
What's a vector? How would you define it? If you're walking on the street and then this old grandmom comes to you and then she's like, hey, what's a vector? What would you tell her? Nothing?
It has a magnitude and a direction.
Yeah. And she's gonna be like, here's a cookie. All right, so here's the idea. We're just gonna be doing for the next questions. We're just gonna add and then we're also gonna subtract. When you add a vector, it always has to be from tip to tail of the second guy, okay? This is when you add them. Let's say this is A and this is B. This guy here is going to be A plus B, okay? But when you subtract them, look at this. A minus B, this is the same thing as saying A plus negative B. So we actually have to flip this guy, yeah? A is as it is, this is as it is, but B, we need to flip it. So instead of going up, it's gonna go down like that, okay?
Mm-hmm.
And then you add from tip to tail. That makes sense?
Uh-huh.
There's another way of looking at the subtraction of a vector, which is like this. We're just gonna do the same thing. This is A, okay? But now the B vector, right? The B vector, I'm gonna move it like here. This guy, I'm gonna move it here. So I end up getting something like this, yeah?
Uh-huh.
So now but this way is a little bit complicated, but it's gonna work. This one was A minus B. This vector going this way down. Same thing here. This is A, this is B. We didn't flip the B, this is the original B. And then we're gonna go from here to here, like that. And this is negative B plus A or A minus B. It's the same thing as this one. There's multiple ways to look about it, but I think this one is the best way, tip to tail. Just stick with one rule so it's not as confusing. XY, very simple question. X plus Y. Here, here, here. Something like that for A. You agree with this?
Mm-hmm.
What about B? How do we go about doing B? X minus Y becomes what? X plus negative Y, yeah?
Mm-hmm.
So X you would draw as it is right now. It's going this way. But then the Y, you have to flip it. So instead of Y going down, it's gonna go this way up. And then you start here, go all the way there, and boom, that's gonna be X minus Y. Same thing with Y minus X. I mean, so start with the Y first, this. Minus X means instead of it going the other way, it's gonna go down this way. This is gonna be Y minus X. Finally, negative Y, negative X, flip both of them. So negative Y is this. Then we're gonna add negative X to this. So this is gonna be negative X, that's negative Y, and tip to tail. Boom, and this is gonna be negative Y plus negative X. That makes sense?
Yep.
It's just a triangle, right? It's not that complicated. This bit anyways. Um, Here's a quick question. Do you think the order matters? Like, would it matter if I did A plus C first and then B? What's the hypothesis? Does displacement care about the order? Like the
No.
path it takes? No, the order does not matter. So let's look at this. We can prove it right here. Construct A plus B plus C. So to do A plus B plus C, this is in a bracket. We're gonna construct B plus C first. So this is B, this is C. So this guy right here is going to be B plus C, yeah?
Mm-hmm.
B plus C. And we're gonna add A to this. So if that's B plus C, I'm gonna add A to this like that. So we end up getting something like this. That's the final answer, like something like that. That's gonna be A plus B plus C. Now, if we do part B, A plus B, so we had this, then we had this. something like that. This guy right here so far is a plus b, and then we're going to add the c vector to this. So c vector is going straight down, and you end up with something like that, which is the same thing as this guy here. Okay, so the order doesn't matter when you're adding them, or even when you're subtracting them, the order doesn't matter. You can pick any two to begin with. Here's a tricky question, which would be this one. Question 6. What does the C stand for? The C that's outside, like here. You see this C?
Mm-hmm.
What does that stand for? Cookies, right?
No.
No, it's communication. So basically you have to explain how you got the answer. You're gonna have to kind of prove this. Okay, MQ. So this is MQ. All right, cool. So let's start. X plus Y. So give me what X plus Y gives. It's gonna give a certain vector. What's X plus Y equals to? Look at the diagram. We're adding this guy with this guy. What does that give? Tip to tail, right? It's gonna give us MS, no?
Mm-hmm.
What about Z plus T? What does that give? Z is here, T is going this way. If you add these two, what does that give?
QS.
Nope. Look at the direction, not QS. It always starts here from the first vector, right? It's going this way. It's not QS. What is it? It's
SQ.
SQ. Yeah, exactly. SQ. Right? The direction matters. The path doesn't, but the direction does. So we have, okay, now if I add MS with SQ, what do I get? SQ is going this way, MS is going up.
MQ.
Yeah, and that's it. So MS plus SQ gives you MQ, and you're done. Okay?
Mm-hmm.
This side has what should we call this? This diagram has 5 sides. Um, what is its name? What is a 5-sided diagram called? Now how 3 is a triangle, 4 can be a rectangle, parallelogram, rhombus. What's the name for a 5-sided diagram? So with a P.
A pentagon.
Yeah, exactly. It's a pentagon. How many triangles are there in this pentagon? How many
5.
triangles? 5? Oh, that's actually a trick question, is it? No, there's not 5 right now as we see it. Actually, maybe you're right. We can see the 3 faces here, right? Yeah, I think you're right, because there's gonna be like something like this happening on the other side, which we don't see. So there's 5. I mean, it has 5 faces. Let's do something else. This is another box question that it's gonna be similar to what we did yesterday. My thing. No. Okay. I don't know what happened. All right, so let's do this one, number 7. So they've given us 3 sides, or 3 vectors in terms of X, Y, Z, looks like. And then we need to express everything else in that. Yeah, you understand the question?
Mm-hmm.
Okay, by. What's by in terms of x, y, or z, or any combination?
It's Z.
By is most certainly not z. By is this, right? Z is going up. This would be z. By is equivalent to, in magnitude,
Negative X.
yeah, negative x. Xb. This one's pretty easy. Xb is this guy here.
It's Y.
It's y. OB. So OB would be this here. You have to write it as a combination.
Y plus negative X.
So OB, this guy here is going to be this guy plus this guy. It will be x plus y. Because this one is x. OB is equals to OX plus XB. OX is x and XB is y, right? So therefore, OB is x plus y. What about XY? Which is this vector here. Will be something plus something.
Y plus negative X.
Yeah, that's good. Y plus negative x would do it. OQ. OQ, okay, this one we're going from here to like here. We're going this way. And the idea is I think it's gonna be all three of them now. Because yeah, there's length, width, and a height. What's OQ?
Y plus Z.
Y plus Z may not be enough. No, it's not gonna be enough. That would be OR would be Y plus Z. OQ, so we need to get from there to here. Again, the path doesn't matter, right? I'm gonna go this way first. So X, and then I'm gonna go this way second. Y, and then I'm gonna go this way third, plus Z. So OQ is actually X plus Y plus Z. Y plus Z would be, so Y is going this way, Z is going this way. You would get this diagonal, but we're trying to get from here to here, right?
Mm-hmm.
So it's lacking an X component, so that would be X plus Y plus Z. XR. X from here, we're starting here, okay? We're ending up there, like that. So there's multiple ways you can get there. You can go here, and go here. What'll that be?
Y plus negative X plus
Yeah,
Z.
yeah, perfect. Y plus negative X plus Z. And then finally we have PO. So we're starting here, we're gonna end up there. Like this direction. Multiple ways to get there. What's PO?
Do you go towards the Z or the X?
Okay, so multiple ways to go about it. In fact, I'm gonna probably hit you with 20 here. PO, right? One path would be you go PX. PO would be PX plus XO. So that's negative Z plus negative X. That's one path, yeah? Do you like long walks? Because let's go all the way around this box. We want to go from here to here. I'm gonna go PZ first, and then we can go ZR, and then we can go RY, right? And then we can go this way, plus, and then we can go this way, and then finally we can go this way. That's obviously a dumb answer to this question, but that's also right. Yeah? It can go any way you want. So PO, the best answer would be either PX, so that's negative Z, plus negative X, this way and this way, or you can go this way first, which is X plus negative Z. Actually, it should be negative X plus negative Z, because this way is negative X, yeah. So you can go this way down, that's one path, or this way across, that's another path. Okay? PO. But like I said, you can go all the way around this diagram and get there, but that's obviously not the most efficient approach. Okay, let's try doing this question. So there's a plane. It's flying north, so it's flying this way, yeah? Straight up. The speed is 150 kilometers per hour. That's not that fast, but I guess it's a small plane. When it encounters a wind from 80 kilometers from the east. Question for you. If there's wind coming from the east, which direction is the wind headed?
West.
Yeah. So there's a wind. It's coming from the east. That means it's headed this way towards the west. And its thingamajig speed is 80 kilometers per hour. Okay? What is the resultant ground velocity of the airplane? So the plane is flying north as it is, but then the wind is going to push it, right? So how do we find the resultant? Well, we simply add up both those factors. 150 north, and then you can just add it here. This is the 80 that's going west. Therefore, your net, your resultant, right? The sum. The resultant means the sum is going to be this guy here, going this way. Do you agree with this? This is going to be your resultant. We can call that R vector. Which direction is it going? The plane is going north. The wind is coming from east, going west. In which direction is the R vector going? If you look at a compass, right? It's going this way. Northwest. Yeah? North plus west, northwest. It's going this way.
Do you have to find the angle?
Yeah, good question. Yes, you do. It may not be perfectly northwest. That would mean it's 45 degrees. Perfect northwest is 45 degrees, this angle. Just to be safe, we're going to find the theta there as well. So we want to find R. This is a right angle triangle. How do you find R? You're given two sides of a right angle triangle, yeah?
Pythagorean theorem?
Yeah, super simple. R at this level now, this should come off like instantly. You see a right angle triangle, two sides, probably Pythagoras theorem. So C is the square root of a squared plus b squared. So 80 squared plus 100 squared. That is 128.06 kilometers per hour. Actually, I didn't plug that in right. This should be 150. This number should be greater than, because 128 doesn't make sense. It's a hypotenuse. It should at least be greater than 150. 80 squared plus 150 squared. 170. Yeah, there you go. That's more like it. So the speed is 170 kilometers per hour, but the question is asking us for velocity. We have to specify a direction. Let's find this theta here. How can we find the theta? You want a hint? It's a right angle triangle. Means SOHCAHTOA applies. Which one do we use? Sine, cos, or tan?
Tan.
Tan? Actually, because we know all three sides of this triangle, you can use anything. Okay? Because we also know the hypotenuse, it's 170. So you can use sine, cos, tan. But tan works. So tan theta is what over what? It's going to be something over something. What's the opposite side? Because tan is opposite over adjacent toa. What's the opposite
80
side?
over 170.
80 over, no. If you're using tan, it's going to be opposite over the adjacent. 80 over 150. If you do 80 over 170, that would be sine. Opposite over the hypotenuse. If you do 150 over 170, that would be cosine. They will all give you the same theta. When you do the inverse, they will all give you the same theta. So tan would be 80 over 150. Tan inverse of 80 divided by 150. So the angle is 28 degrees. How do you say that in terms of a compass heading? Like 28 could be anywhere, right? This could be 28, this could be 28, this could be 28. But we need this guy here to be 28. So what's that in terms of northeast, west? To get here, right? Look at what the plane did. The plane went north first, and then it went west. North, and then it went 28 degrees west, yeah?
Mm-hmm.
Does this make sense?
Yes.
North, so that's going to be the direction. There you go. So the velocity is 170 kilometers per hour at a direction of north 28 degrees west. And you are done. Okay?
Mm-hmm.
What's this?
South 30 degrees east.
Yeah. What's another way you can say you can get the exact same line going this way? You got to look at it from this perspective.
East 60 degrees south.
Yeah, that's it. So we're given two vectors x and y. X is 7, y is 24. Is x plus y going to be 31? It's a question for you. Is x plus y going to be 31?
No.
No, it's not going to be. Because if you actually draw it out, that's x, y. I'm going to do y plus x. It's the same thing. We need to move the vector, right? Tip to tail. We need to move it, so you got a tip to tail here. Therefore, your x plus y is gonna look like this. This guy here is x plus y. And if that's 90 degree, this also must be 90 degree. Y is 24 units, x is 7 units. How do you find x plus y?
You find the hypotenuse.
Right, you just use the Pythagoras theorem, find the hypotenuse. So square root of 7 squared plus 24 squared, the answer is 25. So this is 25. And it says calculate the angle between x and x plus y. So which angle are we looking for? It says between x and x plus y.
Like the top one.
Yeah, the top one. Which one do we use, sine, cos, or tan? Remember, we have all three sides.
You can use any.
Correct, you can use any. Tan theta is equals to 24 over 7. Sine theta equals 24 over 25. Cosine theta, 7 over 25. All these, when you do the inverses, they'll give you the exact same angle. So tan inverse of 24 divided by 7, that is 74 degrees. And that's going to be the answer. Okay? Is this difficult?
No.
This is basically just SOHCAHTOA and Pythagoras theorem. The only added thing is the element of vectors. The next one is not going to be as easy, but it's the same idea. AB and AC are two unit vectors, and the angle between them is 150. So let's quickly sketch them. It doesn't matter which one is which, but we know this is AB. Let's say this is AC. You can make the top one AC as well. It doesn't make any difference. And we know the angle between them is 150 degrees. And we know that they're unit vectors. What's a unit vector? A unit vector is a vector that has a length of 1 unit. Okay? The magnitude is 1, as it says up there. The length is 1 unit. So is the answer 2? If we add them up, 1 plus 1 is 2. Is that correct? AB is 1, AC is 1. Therefore, AB plus AC must be 2. True or false?
False.
False, big time false. A big zero kind of false. So how do we do this then? Is it in the right orientation, the two vectors, for them to be added up? It's the idea about tip to tail, yeah? That's the only way you can add them. Right now, they're tail to tail, correct? So what I'm going to do is this AB vector, I'm going to move it up here. So this now is AB. And this is good because now we have tip to tail right there. Therefore, your resultant vector, when you do AC plus AB, start from the origin, wherever you started from, of the first vector, and this is going to go all the way to the ending of the second vector, okay? Make sense?
Yep.
2 points. What is this angle? Is this 150?
No.
What is it? They are the supplementary angles of a parallelogram. They add up to something.
Is it 30?
It is 30, yes. So that's 30. We know this is 1 unit. We know this is 1 unit. We're looking for it's not a hypotenuse, so we shouldn't call it the hypotenuse, but the resultant vector up here, AB plus AC. Pythagoras theorem, would that work here?
No.
Why not? Yeah, that's right, it wouldn't, but why? When can you use Pythagoras theorem?
Only when you have a right triangle.
Correct. We have no indication that this is a right triangle, this is a right triangle here, okay? We only know one angle of the triangle. We don't know what the other two are. So Pythagoras theorem is out. What do we do then? In a triangle, when you can't use Pythagoras theorem, what do we do? You got to use something else. You're going to use the sine law or the cosine law, depending on the problem. In vectors, I'm going to tell you, most of the time it's going to be cosine law, because cosine law you can use when you have side angle side. Side as in like side here, and then there's an angle between them, and then you have another side here, okay? SAS, side angle side, you're going to use the cosine law, which says this. It's very similar to the Pythagoras theorem, except it has this added bit here, minus 2ab cosine theta. Cool?
Mm-hmm.
For us, this side is C. This side, okay, A and B doesn't matter. C is the one that matters. C is always going to be the side that's opposite to the angle that we have. A and B can be anything. This could be B, the other one could be A. It's not a big deal. Only C has to be opposite from 30. So therefore, C squared is A is 1, B is also 1, times 2 times 1 times 1 times cosine 30. And then you just square root it and you'll get C. So 1 plus 1 minus 2 times 1 cosine 30. Square root this guy. C is therefore 0.52. Okay?
Mm-hmm.
Units, I guess you can call it units or whatever. And you are done. Easy peasy. Main takeaway ideas, adding vector tip to tail, and supplementary angles of a parallelogram, and finally identifying that it's a cosine law problem. So SOHCAHTOA does not work. Okay?
Mm-hmm.
And that's it. That is it. This one looks difficult. If PM equals MQ, so this is the same thing as this, and this thing is the same thing as this. Prove that 2RM is TP plus SQ. There's a lot of words going on. I guess this is S. Um, any ideas on how to go about this? Probably not, and I don't blame you. Let's go step by step. This is not actually, it looks very difficult, but you just gotta, it's just adding vectors, okay? You see RM here, this guy?
Mm-hmm.
We're gonna write RM in terms of this path first. That'll be one way to write RM. So what's that? If we go this way, it's negative B, yeah?
Plus TP
Yeah, and then what's the last one?
plus A.
Yeah, plus TP plus A. Now we're gonna do the same thing, except we're gonna go from the right side. We're gonna go this way. So what'll that be?
B plus SQ
Yeah,
plus negative A.
yeah, right? And then they want to, well, let's just add them up. RM plus RM gives us 2RM. Negative B and B cancel out. A and negative A cancel out. So therefore 2RM is TP plus SQ and proved. Easy peasy. right? So it's just checking if you know how to go get the same vector using different paths. That's all this question is. It's not too bad. Yeah?
Mhm.
Not gonna get into this question. Do you know what a median is? We're not gonna do that question yet, but a median is when you draw a line from a triangle's vertex, and then that goes to the midpoint of the other side. You see this line here? This is the median
Mhm.
line. That's what that is. Don't worry about that. That looks to be an unknowing question. Okay, next part is something called vector multiplication. And this is very simple as well. This is just like algebra, like we do with polynomials. Like you know how x squared times 2 is 2x squared?
Mhm.
Same thing with the vectors. Vector A times 2 is 2a. That's it. That's literally it. That's the main idea behind it anyways. Um, there's another idea of something called collinear. Let's say you have some vector A, okay, going this way, right?
Mhm.
And then directly on top, actually, I can also draw this on the side, 2a. 2a is also going in the same direction. Do you agree?
Yes.
Now, if you were to superimpose, put them on top of each other, they would look something like this. Like it'll be on top of each other. They're the same line, yeah? So
Mhm.
this is called, these two vectors, a and 2a are collinear. They're directly on top of one another. They represent the same line and they're on top of each other. It is also collinear with this vector here, negative a, vector negative a. Because if you superimpose, it's gonna be on the same line. It's just going in a different direction, but it's in the same line, okay? So if
Mhm.
they all lie on the same plane, they're collinear. For example, 5a, 2a, a, negative 1 over 2a, 6a, all these guys, they're on top of each other. Some are going up, some are going down, but they're all on top of each other. And that's called collinear. The only difference is the multiple, the number, the leading coefficient that they're being multiplied with. Okay, that's the only difference between vectors that are collinear. Righty. This question, again, this is gonna be the parallelogram law question that we did before. So there's x and y, doesn't matter where they're going. Let's say this is x, this is y. The only important thing is that the angle between them, you see this in the middle? That's 30
Mhm.
degrees. Calculate the value of 2x minus y. Step one, always draw it out because it'll make your life way easier. And there's points attached to the drawing as well. So let's decipher how to draw 2x minus y. So this is x, right?
Mhm.
X is a unit vector. That means it has a length of 1. Let's draw 2x. So this is x so far. This is x. What's the length of 2x? Remember, x is a unit vector. It has a length of
Is
1. It's 2, right? And then we got to do a little flippity on the y because it's minus y. This one is plus y, right?
Mhm.
What I'm going to do is I'm going to go here and then flip it like that. And that's going to be minus y, correct?
Uh-huh.
So this will be minus y, and it also has a unit of 1. And therefore, your resultant vector is right here. This is 2x minus y. Cool?
Mhm.
10-point question. Again, I'm going to give you a hint what we just drew. What's this angle here? That's the same as this angle here.
30.
Yeah, perfect. It's 30. So it's not 150 like it was last time. Okay? Because that was the addition. You have to flip it. If you draw it out, you can see it. But when you're subtracting it, the angle stays the same. So we're looking for this guy here. How do we find it? Is it sine, cosine, tan, SOHCAHTOA, Pythagoras? Side, angle, side. It is, the Pythagoras is out. It's not a right angle triangle.
Cosine law.
Cosine law. Do you remember what it was?
It was kind of like the Pythagoras theorem.
Yeah. So it's c squared equals a squared plus b squared. This is literally the Pythagoras theorem. And then there's the added component of minus 2ab cosine theta. Okay, like that. Where c is always the side that's facing opposite the angle. So therefore c is going to be the square root of that. So 2 squared plus 1 squared minus 2 times 2 times 1 times cosine 30, like that. 2 squared plus 1 minus 2 times cosine 30, square root of this guy. Therefore, that side is 1.24 units or meters, whatever this is. There's no units, so we can just call it units. Cool?
Mm-hmm.
That's part A. Part B now is asking you to find the direction of it as well. Okay, not a problem. The only issue here is we don't know, like, if that's north or south or east or west, because it didn't say which direction it started off as. What I mean by this is this exact diagram, you can draw it like this. You see this is going to be a resultant. Here it looks like it's northwest. Here it looks like it's something else. It's like it's northeast. Yeah, we don't know the compass heading of this diagram. So when we find the angle, we're going to say it relative to the other sides. We're going to say it's 30 degrees away from vector x, or like 20 degrees away from y, or something like that. This is your x vector. This is your negative y vector. Okay, let's find this angle here. Any ideas on how to find that? I'll give it to you. So now for this one, you're going to have to use the sine law. Okay? You use the sine law. When do you use the sine law? You use sine law when you have at least one pair of things. By pair, I mean the side length C and the angle attached to it. The side length A or the angle attached to it. When you have at least one full pair, then you're going to use the sine law, okay? And sine law says this: sine A over A is equals to sine B over B. It's basically a ratio, a proportional ratio. It also says equals sine C over C, but usually you just use you use two things at a time. But the rule applies to any three sides of the triangle. To set this up, I'm gonna say this one and this one are A's, okay? So you get sine 30 divided by the side opposite to it, so 1.24 is equals to, we're looking for this, we don't know what that is, we can just call that sine B. What's the side length up opposite to this angle?
Y.
Yeah, y, and it's a unit vector, right? It's 1. So sine B over 1. So you can just ignore the over 1 bit. You have this equation, so sine 30 divided by 1.24 is 0.40 equals sine B, right? How do you find B? We have sine B, we want to find B. You just do the sine inverse. Whenever you're trying to find the angle, when the angle is missing, you're always going to do the inverse. So therefore B is the angle that we're interested in, this angle down here, B. It's going to be the sine inverse of 0.40, okay? Which is 24 degrees. So therefore, this 2x minus y is 24 degrees away from the x vector. Cool? Again, this is the same thing that we did before. The added component now is the sine law, because they're asking us for this angle down here. And that's what they got as well. Again, step one, you're always going to sketch. Plane is flying north 30 degrees east. So is that this first, the top angle, or is that the bottom angle? North 30 east.
The top.
The top one, exactly. 30, and its magnitude is 240. Draw a sketch of negative 1/3 v and state the direction of this vector. So negative means it's going to be going the opposite way, right? And 1/3 means, well, it's going to be 1/3 of this. So let's say, what's 1/3 of 240? In other
80.
words, yeah, 80, yeah, exactly. So that magnitude is going to be 80. So let's say from here to here, it's 80. And then it's going this direction, right? That direction. Like that, you see? This is the direction, but the magnitude kind of just stops like 1/3 of the way there. What's the direction of this vector? Remember, it's the opposite. It's the opposite of this guy.
South 30 degrees west.
Yes, and you can see that, right? Because this angle and this angle are opposite. So this must be 30. To get here, you first go south from the origin, and then you go 30 degrees west. So it's going to be south 30 degrees west. Yeah? 3/2 means the exact original thing that we started with, except now it's 1.5 times longer. In other words, it's going to be 360. 240 times 1.5 is 360. So the magnitude of that line is 360. What's the direction? Notice it's going in the same direction as the original vector, so direction doesn't change. Okay? So that thingamajig does not change. So it's going to be north 30 east as well for part B, because it's going in the same direction as the original. We saw this word before, unit vector. Do you remember what that means? It's a vector and it has a special magnitude of 1.
Mm-hmm.
It has a magnitude of 1. Unit vector magnitude 1. So again, this one we can just kind of like rush this a bit because we've done this many times. The only difference is we're adding them. So let's say this is U. Let's say this is V. The angle between them is 150, right? 120, sorry, 120. And we have to move one of them. So I'm going to move this guy here, tip to tail. So my drawing is going to end up looking like this. So this is 4 units, this is 5 units. What's this angle here? No, actually, we need this angle. Yeah, we need that angle because this is a resultant. What's this angle here? Remember, it's a parallelogram, yeah? See, these two are the same drawings. If this is 120 here, what's this angle here?
It's 60.
It's 60, yeah. Like that. How do we find this missing side up there? It's a side angle side question.
Cosine law.
Cosine law, exactly. So u plus v, that side is going to be a squared plus b squared minus 2ab cosine theta, like that, and the square root of this. So let's plug this in. So 4 squared plus 5 squared minus 2 times 4 times 5 times cosine 60. The answer is 4.58. Is this a unit vector?
No.
Because it's not 1, yeah?
Mm-hmm.
Mm, not sure what this question wants. Determine the unit vector. So this is the direction. No, that's not the direction. This is the direction. We found it. This was 4.58. Okay, I think I know what that wants. They want the angle because we don't know what direction this is going to, right? See that?
Mm-hmm.
Can call this theta again. How do we find that angle?
Sine law.
Set it up. Something over something equals something over something. In fact, I'll give you, that's gonna be signs on top.
Sixty over 4.58.
Yeah. What about on the other side?
Something over 4.
Sine theta over 4, exactly. How do we solve this equation for theta?
You multiply by 4.
Yeah, and then?
And then do inverse.
Correct. You wanna try it? Do you have a calculator on you?
Mm-hmm.
Try to give me the angle. What did you get?
It's giving me error.
Okay, we can do this one by one. Type in sine 60, press equals to. And then you know where the answer button is, right, on your calculator?
Mm-hmm.
You just do answer times 4. Divide by 4.58 equals 2. And then you do sine inverse, which is the second function sine. Okay, sine inverse is second or shift, whatever it is on your calculator. Sine inverse of answer and equals 2.
Get
Yeah.
49.14.
So what were you doing wrong? It's probably the syntax or the order of operation, right? On the
Mm-hmm.
calculator. It can be a bit picky. Let's try doing quickly something here. Which one looks kind of weird? They all look weird, I guess. Okay, we can do this one. So we know AB is A, this vector is A, and BC is B, yeah?
Mm-hmm.
Okay, cool. Express CD, you see this vector? In terms of A and B. If this is A, what is this vector here?
It's negative A.
No, it's A as well, because it's going in the same direction, right? This one.
Oh, mm-hmm.
If that's B down there, what's this vector?
It's also B.
It's also B. Right, CD. So we want this vector, right?
Mm-hmm.
From here to here in terms of AB. Let's call this vector K or C, okay? Would you agree? This is C. Then this
Mm-hmm.
up here also must be C, yeah? So now check this out. CD, how do you get C to D? We're gonna go this way. So CD is minus B minus A, yeah?
Mm-hmm.
Plus some vector C plus B plus A, right?
Uh-huh.
Does that help us? We just get CD is vector C. Does not look like that path helped us. Um, what if we first find this vector, AC? You see this guy here?
Mm-hmm.
What's AC? AC is going to be A plus B, right?
Mm-hmm.
What's FD? This guy here.
B plus A.
Yeah, B plus A or A plus B, it's the same thing. Now, let's do the CD thing again. To do CD thing, I'm gonna bend this. This becomes minus A minus B, right? Plus some C vector, and then again, this one here, minus A minus B. So you get minus 2A minus 2B plus C equals CD. This is the same thing as this. You get 2CD is minus 2A minus 2B, therefore CD is negative A minus B. Okay?
Mm-hmm.
So it basically has to do with the path that you take, and sometimes it's going to be a little bit more difficult than others. We'll pick it up next time from here.
All right, thank you.